I'm Kim Prather. I'm a professor of chemistry, distinguished chair in atmospheric chemistry, also the director of CAICE. CAICE stands for the Center for Aerosol Impacts on Climate and the Environment. It's an NSF-funded center centered here at UC San Diego. The goal of CAICE is to basically try and understand sort of how chemistry influences a large-scale problem of some sort. So it's what's called a Center for Chemical Innovation, and these centers pick a problem where chemistry is at the heart of it, and our lack of understanding of chemistry is limiting our ability to solve this much larger problem. And the problem that CAICE picked is environmental chemistry. In particular, it's about aerosols. Aerosols are defined as little bits of soot and dust and sea spray and smoke. It's the stuff that you see come out of the chimney of a house or the tailpipe of a car or the stack of an industrial source. So it's all the little tiny bits and chunks of matter that float around in the atmosphere. And these actually transform, they change the atmosphere. Chemistry that happens on their surfaces changes the composition of our atmosphere in a way that it wouldn't be if they weren't there. And really importantly to CAICE, and one of the major foci of CAICE, is these particles, aerosol particles, go up and they actually act as seeds for clouds. You cannot make a cloud unless you have aerosols in the atmosphere. But not every aerosol particle looks alike. In other words, the chemistry of each particle looks different. And so what we're trying to do is understand how chemistry of each particle influences its ability to form clouds.
At the center have a number of researchers that we work with across the United States in many different institutions. So we bring in these very bright undergraduate students. They participate in our research in a 10-week program. We mentor the students. The students get to work with our state-of-the-art facilities. The students have an opportunity to really integrate with the research that we're doing. We also have a number of professional development programs for the students so that they really can take advantage of what CAICE has to offer, what the universities that participate in CAICE have to offer.
I chose to do research with CAICE over the summer because I'm passionate about protecting the environment. And the reason I got into chemistry in the first place was to help protect our oceans and clean up all the plastic waste that's gotten in there. So to help out with the CAICE program and studying sea spray aerosols and how it affects the global climate as a whole, I think falls into my overarching goals of understanding and protecting the planet.
I chose to do research with CAICE because I was looking for a really good first research opportunity, and what drew me to CAICE was there was a variety of labs that had very interesting research.
I was really interested in learning more about aerosols and the environment. And my mom's she works at the Department of Ecology, and she really talks about the environment to me. And I didn't just want to study research, the aerosols on an experimental level. I wanted to use the computational methods that I had learned at my home institution at the University of Washington.
This summer I had looked at the aging of sea spray aerosols, so the effects that an aerosol would have over a course of time affected by sunlight, having no ambient air, there is an effect that it would have on the composition, how it would change.
The research that I do at CAICE is focused on investigating aerosol surfaces, and the behavior of the surface of an aerosol is very important because it affects the optical properties of the aerosol, and the surface is the interface between the aerosol and the environment.
This summer I've been primarily focused on researching ice nucleating particles. Mainly I've been trying to develop a method to quantify even chain fatty acids in ice nucleating particles because we believe that these play a major role in ice nucleation.
I had worked with a lot of different instrumentation that I had never been exposed to before, such as Raman or an HDMA, Moody. So by working with this new skill set, I think it'll make me more competitive here on out, having those new skills.
I've developed some professional skills in data entry, data analysis, communication, presentation, problem solving, helping design experiments, collaborating with other researchers. It's been a good experience.
I've learned how to present my research in a very effective manner, both orally and through posters. I've learned how to synthesize data and present it in easy to understand ways, which I think is crucial to this field.
We had the great honor this summer to be lectured by Dr. Mario Molina, who won the Nobel Prize in chemistry for his work in discovering and remediating the ozone hole over the Antarctic. He was the first Mexican national to win the Nobel Prize, and being Mexican American on my mom's side, it's very inspiring to me to just even be in the presence of Mario Molina. And currently Mario Molina is now, he's given so much to the global community as a whole, and he's giving back to us undergrads by doing these very intimate lectures.
It's really important for scientists to be able to explain their research and explain not only to other scientists, but to be able to explain it to the general public.
We did this outreach event. It was definitely CAICE related, so we did aerosol, we did cloud experiments, cloud in a bottle, we did some isonucleation experiments. It was really cool. All the high schoolers loved it.
The outreach was a lot of fun. It was cool being able to work with these high school students and show them what is being done in CAICE, and I hope that it made them more interested in the atmospheric sciences and want to look more into it.
Things that I've done for fun during the summer is go to Comic-Con International, gone surfing, and went to Mexico several times.
I'm from the East Coast, so West Coast is completely different. I was able to do a lot of sightseeing, LA, Universal Studios. The beaches are completely different out here.
We actually went surfing the other day, which was pretty fun. It was my first time surfing. I've ever done that, which was interesting. I didn't catch so many waves as the waves caught me, but it was still a good time. I still really enjoyed it.
The most inspiring part of CAICE, I would say, would be just the intense amount of interdisciplinary collaboration that happens in this program. It's definitely something I've never seen before. You have biologists, you have physicists, chemists, all coming together to work to this one common goal.
I really enjoy the collaborative effort in CAICE. The fact that several labs across the country are working with the same goal in mind is amazing to me. I think there needs to be more collaborative efforts.
What I've seen going into the different labs and watching the students do research this summer is that they're really making a lot of progress. A lot of students are now using instruments for the first time they've never used before on their own. They are going and answering questions about aerosols, these small particles that before they came to the program they weren't even able to formulate what those questions would be. So I've been really impressed with how the students are doing this summer, and I think it's been a really a big success in terms of where they were and where they are right now.